So the first thing we're going to talk about are reflections. It describes several transformations here. The first one we're going to look at is reflection, which is, what you think of when you think of any reflection. And you'll notice that with a reflection, it flips across something. In this case, we have a vertical line. You'll also notice in reflection that it changes the way it is facing. So this ABC is facing this direction and it flips and now it's facing the other direction. The second one we're going to talk about today is a translation where it's just sliding. It's facing the same direction, it's just sliding. And then the third one we're going to talk about, which we're going to talk about next week, is a rotation where you have some point and it just revolves around that point at a certain degree. All right, so let's first talk about what a transformation is. A transformation, and you will need to know this terminology. You'll have some terms on your test. A transformation is a mapping function that produces a movement of points. A mapping function that produces a movement of points. All right, pre-image. Pre-image is what you start with. So like for this reflection, this would be the pre-image. Pre-image is what you start with. And then the image is the result. So in this reflection, the image is the result. You'll notice that in the notation, you have ABC for your pre-image and you have ABC, but with a little dash above it for the image. So once it has been moved, you put little dashes on it to indicate that is the moved figure. All right? There is some notation when it comes to actually looking at these. So we have triangle ABC right here. And then you have this arrow. This arrow indicates that it has been mapped onto a new image. And you'll see that triangle A with the dash above it, or A prime as it is read, B prime, C prime. Order matters. So if A is first, then A prime has to be first. If B is second, B prime has to be second. C is third, C prime has to be third. So they do have to be listed in the corresponding order that the image and the pre-image are on top of each other. And so the first example they give us is just using that information. They have triangle RST is mapped to a new location somewhere, depending on what they did, to triangle XYZ. The image of R, remember pre-image is where you start. So if they want the image of R, that is going to be X, because R and X correspond to each other. All right. Pre-image of Z. Z is here. Pre-image would be where it started. It started at T. So the pre-image would be point T. The image of RST. That is the entire triangle. This is the pre-image. So the image would be triangle X, Y, Z. Just know your terminology. Know your terminology. Because there will be times when it says give the coordinates for the pre-image or give the coordinates for the image, and you need to know which one it's talking about. So first of all, what does a reflection look like? What does a reflection look like? I'm going to scoot these guys down a little bit. All right. It flips it across something. There are going to be times when it flips it across an axis or a line. But either way, whatever it flips across is called the line of reflection. Another term you need to know. The line of reflection is the mirror that it goes across when you're creating the image from the pre-image. All right? If you were to construct this, it's actually a perpendicular bisector between the points, okay? So what actually happens is this line L, which is the line of reflection, becomes a perpendicular bisector between Y and Y prime, between Z and Z prime, between X and X prime. So you could actually construct a reflection by constructing perpendicular bisectors and then measuring the distance from the bisector to the point to get the bisector to the image. All right, so bisector to the pre-image, bisector to the image would be the same distance. All right, it is a perpendicular bisector between those points. And so we're not going to do the construction, but you can actually construct it by using your method of constructing a perpendicular bisector, which is what they show you right here. So they have this pre-image here. They have the line of reflection, which is K. And all they've done is they have constructed perpendicular bisectors from each of the points. And then they've measured from N to the bisector. And that's the same distance from the bisector to N prime. And the result when you do that is this 3 points. You connect them and you have the reflected triangle. All right. So let's look at the actual definitions here. A reflection in a line L is a transformation that maps each point P onto the point P prime such that if P is on L, then P equals P prime. If P is not on L, then L is the perpendicular bisector. Perpendicular bisector. All right. So let's look at what that means in the coordinate plane. In the coordinate plane. All right. So we're going to do one and then we're going to look at the handout. I do want to talk about orientation here. The term orientation is the relative order of the vertices. And so when you reflect, your orientation does change. Okay, your orientation does change. The next section where you just slide it around the coordinate plane, orientation does not change. It's in the same order. And so we've talked a little bit about orientation when we've done different figures, like when you just did your volume or your surface area. Sometimes you had to look at it a different way than what it was just sitting on the paper. Because if you were looking at the base and you just automatically assumed what was on bottom was the base, you could be wrong because the orientation was different. And so that's what we're talking about when we're talking about reflections. You'll notice that this goes L, M, N. But when I have reflected it, it's M, L, N, right? And so it actually flipped orders. So it was going L, M, N this way, but now it's going L, M, N that way. And so you should see that in reflections. If you don't, then you probably reflected incorrectly, all right? So you should see your orientation change with a reflection. So let's look at this example, example 3 in your book. Given PQR, and they've given us the coordinates for PQR, 3, 4, 1, 0, and 5, 2, find the reflection in the x-axis. So what they're telling us is we are going to take the x-axis, which is this right here, and we are going to reflect across from it. So we should be the same distance on either side of that. And so the first thing we're going to do is we're going to graph these points. We have the point 3, 4. You want to plot it and you want to label it P. You have the point 1, 0. And then you have the point 5, 2. All right. And so we have a triangle here. And they want us to reflect it across the x-axis. So we'll start with the easiest one. We'll start with Q. If it is on the line that you are reflecting, it does not move. Okay? It doesn't move. Because it is no distance away, and when you reflect it, it will also be no distance away. And so for the Q prime, it's going to stay exactly where it is. It is on the line of reflection. For everything else, we're just going to count how many units we are away and reflect across it, all right? For now, we're going to do it another way. So for this, R is 2 away from my line of reflection. So I'm going to go down here and I'm going to go 2 away. My R prime should be right here. For my P is 4 away. So I'm going to come down here and I'm going to be 4 away on this side, P prime. And so once I have my 3 points, Q prime, R prime, and P prime, I can connect it, and I have reflected it. So, first of all, in layman's terms, a reflection is just what happens when you flip a figure across the line. You're basically just flipping it across that line, all right? You're flipping it across. The reflection just takes it and it flips it across the line. All right. When reflecting a figure across a specific line, corresponding parts from the figures will be the same distance from the line of reflection, but on the opposite side of the line, it will create a mirror image with the line of reflection as the line of symmetry. Line of symmetry. Line of symmetry between those two figures. So the figures will be the same distance from the line, but on opposite sides of it, it will create a mirror image. And the line of reflection is the line of symmetry between the two figures. In this particular case, we have taken the triangle ABC, just like we did in the example from the book. And we are reflecting it across the x-axis. All right, so that's right here. So we are going to look at the coordinates first. The coordinates for A are 2, 2. Those are my coordinates. The coordinates for A prime are 2, negative 2. The coordinates for B are 4, 7. The coordinates for B prime are 4, negative 7. The coordinates for C are 10, 7. And the coordinates for C prime are 10, negative 7. You should see some type of pattern. What's the pattern when you go from the pre-image to the image coordinates? The y is just negating. So the coordinates are staying the same, but the y is actually negating. And that is actually the rule when you're going across the x-axis. All right, so we are talking x-axis. The rule is that you keep the x coordinate the same, and you use the opposite sign for the y coordinate. Whatever the y coordinate is, you just make it the opposite. So in this case, all of my y coordinates were positive, so that's why each one became negative. Had any of those been negative, they would have become positive. So when you are reflecting across the x-axis, you change the sign of your y coordinate to get your new coordinates. Your new coordinates will be the same exact numbers, but you will change the sign of the y. So algebraically, what it looks like is it will go from xy to x, negative y. It will go from xy to x, negative y. From xy to x, negative y. All right, let's look at y-axis. Next page. We'll look at these coordinates. For A, B, and C, you have 2, 2, 4, 7, and 10, 7. Same exact figure, but we are now going across our y-axis. So we are reflecting across the y-axis. All right, my new coordinates are negative 2, 2, negative 4, 7, and negative 10, 7. What happened when I went across the y-axis? I negated what? My x. So in this case, you do the opposite for your x, and you keep the y. So for your axis, whatever you are reflecting across, you switch the other sign. When you're reflecting across the x-axis, you switch your y. When you are reflecting across the y-axis, you switch your x. So the algebraic rule here is you would go from xy to negative xy. So go ahead and try 1 and 2 at the bottom of that page. All right, so you need to check your work. One thing I want to point out is when you do these, your shape should be congruent. All right, there are going to be translations that we do and changes that we do that will change the actual shape of the figure. It will skew the size. But this is not one of them, okay? So when you reflect, the figure itself should be congruent. It should be the same exact figure. It should just be flipped over on the graph. All right, so if you start to connect your dots and the figure that you connected looks different than the figure that you started with, you did something wrong in your coordinates and you need to check it. All right, you need to check your coordinates. All right, let's look at the bottom. Label each as A, reflecting across the x-axis, B, reflecting across the y, or C, neither. We have 5, 4 to negative 5, 4. What changed? My x changed, so what am I reflecting across? I'm reflecting across the y-axis, So that's B. What about 4? Negative 10 to negative 10. Is that x or y or neither? That's neither. Both actually, I mean, they changed, flipped places and changed, right? 0, 1 to 0, negative 1. What changed? My y changed, so what is it? A reflection across the x. Negative 6, negative 7, positive 6, negative 7. What changed? My x changed. So what is it? Reflection across the y. 8, 8 to 8, negative 8. Reflection across the x. 1, 3 to negative 1, negative 3. Reflection across what? Yeah, neither. They have given you, so here they have given you an image, and they have given you this line right here in the center. All right, this particular line that they have is the line y equals x. All right, this is the line y equals x. And so let's look at these coordinates. The coordinates for the pre-image A are negative 5, positive 6. Negative 5, positive 6. For B, we have negative 8, positive 4. And for C, we have negative 2, positive 2. All right, those are my coordinates for my pre-image here. And then they reflected that across my line y equals x. So let's look at my new coordinates. My new coordinates for A are positive 6, negative 5. Positive 6, negative 5. My new coordinates for B are positive 4, negative 8. And then my new coordinates for C are positive 2, negative 2. What did they do? So all they did was switch their x and y. All they did was switch their x and y. Right? And so when you're reflecting across the line y equals x, you are going to switch your x and y. What it will look like algebraically is you'll go from xy to yx. You just switch them. All right? You just switch them. And so let's do one. Look at it right below there. So we've given the coordinates J, K, L, which they still have A, B, C listed, so you can fix that if you want. So we have J, K, and L. All right. So we have J prime, K prime, and L prime. All right. So let's look at this one. We have, we're going to reflect this across the line y equals x. And so that line is going to be right here. Y equals x is what we are reflecting across. And so we have to first find my coordinates of my pre-image. So my coordinates of J should be 2, negative 5, right? My coordinates for K, 2, negative 3. And my coordinates for L, 5, negative 5. So I have my coordinates and I have my pre-image. What I need to do is find my new coordinates and graph it, okay? And so to find my new coordinates, I'm just going to switch those. So my J prime is going to be what? Negative 5, 2, right? My K prime, negative 3, 2, and my L prime, negative 5, 5. And then I'm just going to graph it. So I go to negative 5, positive 2. I go to negative 3, positive 2. And then I go to negative 5, positive 5. All right. Translation is another type of transformation. Basically just slides the image around, It can slide it in multiple directions, so it can go left, right, up, and down. All right? You actually, if you reflect across two parallel lines, you get a translation. You basically just get it to slide across. All right? The description that is used is called a vector. So we're actually going to use this term vector, and we're going to use that notation. All right. So we have a vector here. It's a directed segment. And it has this little line with a little half arrow above it. So it actually has a lowercase and then a half kind of ray above it. The half arrow is because it's direction. So translations have a specific direction that they go in. All right. Again, you can think of it as these parallel lines, and then they go a certain distance. All right. And the length of it is how far you're going. All right. Sometimes the way that they're going to actually notate it is they're going to notate it with this little, not really your parentheses, but it's almost a broken parentheses there. And basically what this is telling you is it's telling you how you're going to move your X and how you're going to move your Y. All right. And so when you have this little A, B type thing, this first one is telling you direction of all your X's. The second one's telling you the direction of all your Y's. And you get this set up, and you'll use this later in like physics, but you get this set up from the Pythagorean theorem. But you're basically saying if I start here and I go X a certain distance, and then I go Y a certain distance, technically I've gone from my starting to ending point, my hypotenuse. And so that's what that vector is actually telling you. It's telling you how you're moving. We are just going to use basically adding and subtracting from your points. Adding and subtracting from your points. So first, the definition of a translation. The definition of a translation is described by the vector AB, and it maps every point of P of the preimage to the image such that they're all parallel. So let's look at example 3. Use the vector to translate it. So the first thing you want to see is how is the vector moving? So direction matters. So this vector starts at this point and ends at this point. It went to the right 2 units, okay? So my X is going to be a positive 2. It went down 4 units. So my Y here is going to be negative 4. So that's what that vector would look like, 2, negative 4. And then you are going to take every single one of these and move it 2 to the right and 4 down. Now, the way that you're going to do it when you start translating these is you're going to do your coordinates. But if you just have the image and you're just moving it, you can literally walk it. So if I start at D, D needs to go 2 to the right and down 4. So we're going to 2 to the right and down 4 with D. That will be my D prime. C, 2 to the right, down 4. And that will be my C prime. And we're going to do this with every single one of these. until we have all of our movements where we need them. And then once we have all of our movements, we're going to just connect those. You will notice that the orientation did not change with the translation. It won't. Reflections actually flipped the way it was doing. Translation slide it. So the orientation should not change on a translation. If it did, you did something wrong. So let's look at your handout. Look at your handout. We did a translation here of 1, -4. Means every x moved 1, every y moved -4. So let's do our coordinates here. The coordinates for s are -2, 0. The coordinates for s prime is -1, -4. The coordinates for t are -3, 2. And for t prime, -2, -2. For u, we have 2, 4. For u prime, we have 3, 0. And then for v, we have 1, 0. And for v prime, we have 2, -4. What you'll notice is my movement was 1, -4. If you look at all your x's, you added 1. -2 plus 1 is -1. -3 plus 1 is -2. 2 plus 1 is 3. 1 plus 1 is 2. For all of my y's, I subtracted 4. 0 minus 4 is -4. 2 minus 4 is -2. 4 minus 4 is 0. 0 minus 4 is -4. So for all of your translations, you can simply add or subtract your vector to your coordinates. So you can add or subtract, basically what it is, but you're adding or subtracting your vector to your coordinates. And technically it's always adding, but if it's a negative, you're basically subtracting, right? And so you're basically taking your x, y, and you are adding your vector movements for your x, y. And those will become your new points. Those will become your new points. So let's look at the example at the bottom of that page. The example at the bottom of that page. We have JKL. My J is 2, -5. My K is 2, -3. And my L is 5, -5. All right? They want the translation of -5, 6. So if I want all of these, I'm going to say 2 plus a -5 gives me -3. -5 plus 6 gives me 1. 2 plus a -5 gives me -3. -3 plus 6 gives me +3. 5 plus a -5 gives me 0. -5 plus 6 gives me a 1. And those are my new coordinates. So I'm going to say -3, 1. That's my J prime. -3, 3. That's my K prime. And 0, 1. That is my L prime. And you'll see that that whole thing just shifted. My orientation did not change. If your orientation changes on translations, you did something wrong. So go ahead and do those last two on the back of that page. Give the new coordinates and graph your image. Give the new coordinates and graph your image.